So, alerting is about systems informing you of certain situations. And these situations can be just about anything you want. For example, you might want to configure a system to alert you when capacity utilization exceeds a threshold, maybe 80% used. The same goes for performance. Maybe if average latency over a period of 5 minutes exceeds 30 milliseconds, you might want to know about that too. How you decide what your thresholds for alerts like this should be entirely depends on your environment and your requirements, though you will probably want to map them to any already agreed service levels that you have with your customers and with your business units. Other things that are commonly alerted on are failed components and changes in the state of certain services. Regarding failed components, you might want to be alerted about failed drives, failed cache DIMMs, failed switch ports, and other things that are similar to that. And as for services, you'll probably want to know when things like replication fail, or if replication lag falls outside of agreed service levels. You can, and probably should, alert on all of these. And within a lot of these alerts, you can associate them with different levels of criticality. For example, on the topic of capacity utilization, you might want to configure a warning alert for exceeding 80% of capacity, whereas you might want to configure a critical alert if capacity utilization exceeds, let's say, 95%. And it's all well and good configuring alarms like this, but where do you send the alarms to, and who should know about them? The most common alerting methods include Snmp traps, email alerts, cell phone alerts by text message, and secure dial home via the internet. Okay, so Snmp works by the device being monitored. That's our storage device, maybe it's a switch or an array, whatever. It sends Snmp messages known as traps to an Snmp Manager. The Snmp Manager is basically a monitoring application, something like Nagios or any of the other enterprise monitoring tools available. These monitoring tools are then monitored by a team or an individual at an organization, and it's their responsibility for handling the alerts. Maybe they call out an engineer to fix something, or maybe they make a call out to the team who deals with the device reporting the alert. But it's pretty simple. For example, let's say that a control processor in a director switch fails, and the switch generates an Snmp trap and sends it over the IP network to the Snmp Manager application. This application is monitored by the service desk. The guys at the service desk view the trap in their enterprise monitoring app and make a decision. Maybe they call out the on-call person from the storage team. And it's as simple as that. Email and text message alerts are similar. An event occurs that you've configured an alarm for, and when that event occurs, the device pumps out an email or a text message to the relevant people. Also, applications like Snmp managers and enterprise monitoring applications, they can also be configured with rules that maybe take Snmp traps and forward them to people via either email or text message. And last but not least on our list there on the slide, a lot of high-end storage equipment is configured to call home in the event of failures. So this so-called call home usually consists of bundling up diagnostic and event-related information, encrypting it, and sending it back to the operations center of the vendor over HTTPS. So let's say your array is an EMC array. The array will send this data back to EMC, where it will be viewed and analyzed by EMC engineers. And that's alerting. Now let's look at some examples of capacity management.